Parallel lines and triangles. Objectives. 1. To use parallel lines to prove a theorem about triangles. 2. To find the measures of angles of triangles. Okay, parallel postulate. It says through a point not on the line, there is one and only one line parallel to the given line. Okay, so if I have a line, we'll call this line L. And I have point P over here. There is only one line that I can draw through point P that would be parallel to line L. That's what this theorem says. Because if I start to tilt it at all, then it won't be parallel to line L. Theorem. It says triangle Angle-Sum Theorem. It says the sum of measures of an angle of a triangle is 180. So what that translates into is if I have a triangle, let's call this ABC, it's saying that angle A plus angle B plus angle C equals 180. Okay, now I'm going to show you a quick how to de-angle a triangle and prove. It's not a formal proof, but to prove to yourself that a triangle truly has 180 degrees in it. Okay, I have a triangle here. Angle 1, 2, and 3. Okay, now I'm going to prove to you that a triangle, the sum of its interior angles, is 180. I'm going to do this like you were being mean to a bug. I'm going to tear its angles off. So here's angle 2, angle 1, and angle 3. Now, take a moment. I'm going to put these angles together. Give me just a second. And while I'm putting them together, we know that in a straight line, there's 180 degrees. We agree with that. We've used that theorem and that idea over and over again. Well, we're going to use that idea to help us show that the sum of the interior angles of a triangle would equal 180. There we go. And voila. Notice when I put angles 1, 2, and 3 together, I have a straight line right here. And because I have a straight line, that means that the sum of the three angles has to equal 180. The proof of a triangle Angle-Sum theorem requires an auxiliary line, which is a line that you add to a diagram to help explain the relationships in a proof. Okay, the proof of theorem 311, which no one cares about 311, but it's a triangle Angle-Sum theorem. It says given triangle ABC, and it says we want us to prove that the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180. Okay, so first we're going to start off with, now this is one of those rare occasions that we start off with something other than the given. So statements, reasons. Now notice they had to draw a line PR through point B so that I could have a parallel line. So I'm going to say for my statements, draw line PR through B parallel to AC. It should be segment AC. Okay, and this is the parallel postulate saying that you can draw only one parallel line through a point, not on the line. So parallel postulate. Okay, so if I know that these lines are parallel to each other, that means that I know that if this line is parallel to this line, and this is my transversal, that means that this angle is congruent to this angle. Okay, in that same respect, still parallel lines, but now if this is my transversal, then this angle, angle A, is going to be congruent to angle 1. And that's going to be important to our proof. So now I can say angle PBC and angle 3 are supplementary. Now the reason I want to say that they're supplementary is because I'm going to prove that a triangle has 180 degrees in it. So if I can say that this angle plus this angle equals 180, that can help me get to where I'm going. So reason is because angles that form a linear pair are supplementary. Okay, so if they're supplementary, that means that, to start my equation, the measure of angle PBC plus angle 3 equals 180. And that's the definition of supplementary angles. Okay. Now, I also know that angle PBC is equal to the measure of angle 1 plus the measure of angle 2, because I need to get that I'm talking about angle 1 and 2 into my proof. So I'm going to say the measure of angle PBC is equal to the measure of angle 1 plus the measure of angle 2. And this is going to be by angle addition. Okay. Then I'm going to substitute this information into step 3. So I can say that angle 1 plus angle 2 plus angle 3 is now equal to 180. And that's by substitution. Okay. Now, this goes back to what we started with when I was drawing those parallel lines. I can now say that angle 1 is congruent to angle A and angle 3 is congruent to angle C, because if lines are parallel, then alternate interior angles are congruent. Okay. And then I can say that that means that the measure of angle 1 is equal to the measure of angle A, and the measure of angle 3 is equal to the measure of angle C. And that's because congruent angles have equal measures. And then we can finally say, I bet you thought we'd never get here, the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180 by substitution. Example 1. It says, what are the values of x, y, and z in the diagram? Okay, well, it's going to be easy to find x first, so we're going to start there. In this diagram, we have our triangle here, so I can say that 43 plus 59 plus x has to equal 180, because there's a triangle there. That means that when I subtract, and most of you will put in your calculator 180 minus 43 minus 59, and you'll get that x equals 78. Okay, so now if I know that this angle is 78, that can help me find y, because x and y form a linear pair. So now I can say that 78 plus y equals 180. And I'm going to subtract 78 from both sides. and I get y equals 102. Okay, so that means this angle right here is 102. And then to find z, I again have a triangle, and so I can say 49 plus 102 plus z has to equal 180. So then I can take 180 minus 49 minus 42, and I'll get z equals 29. An exterior angle of a polygon is an angle formed by the side and an extension of an adjacent side. For each exterior angle of a triangle, the two non-adjacent interior angles are called the remote interior angles. So if I'm drawing a picture of this, I'm going to have my triangle and I'm going to extend one of the line segments out, and I can call this angle 1, 2, and I'm going to call this 3. Angle 3 is our exterior angle. One and 2 are our remote interior angles. Okay, our first theorem says that, the triangle exterior angle theorem says the measure of each exterior angle of a triangle is equal to the sum of the measure of its two remote interior angles. So if I was going to draw a picture of this, what that means is that angle 1 plus angle 2 is equal to the measure of angle 3. Now let's prove this. Okay, so I'm going to start off with my picture. 1, 2, 3, and I have to add in angle 4 right here so that way we can talk about this. Okay, now this is not a formal proof by any means, but we know that angles 1, 2, 3, and 4, when I add them up because they're a triangle, they're going to equal 180. So I can say angle 1 plus angle 2 plus angle 4 equals 180. Triangle sum. Okay, and then I also know that angle 4 plus angle 3 also equals 180 because they form a linear pair. Okay, so then I can use substitution and say that angle 1 plus angle 2 plus angle 4 equals angle 4 plus angle 3. Since both of them equaled 180, I can replace them. So this is by substitution. And I'm going to subtract angle 4 from both sides, and I get angle 1 plus angle 2 is equal to angle 3 by subtraction. Now, I'm going to have to be honest here. When you go to take the ACT, or you go to take this test when we get ready for this test, some of you are going to forget this theorem. But you'll still be able to calculate the measure of angle 3, because most of you will take the long way out and say, okay, I need to find the measure of angle 4, because you will remember that the sum of the interior of a triangle is 180, and then you'll end up taking whatever you get for angle 4 and subtracting it from 180 and get angle 3. The people that can remember this theorem will do their work a lot faster, but you'll both still get the correct answer. Example 2 says two angles of a triangle measure 53 degrees. What is the measure of an exterior angle at the vertex of each of the triangles? Okay, so first we need to draw our triangle. And we're going to extend it out so we have our exterior angles. Okay, and it said that two of the angle measures was 53. So 53 and 53. Now, most of us, if we want to find these two angles, we're going to say, okay, they form a linear pair, so I'm going to take 180 minus 53. And you get that those angles are 127. Okay, now, Some of you will use the previous theorem and say, okay, I know this angle measure is equal to 53 plus 53, and you're going to say, okay, that makes it 106. And you're going to be done. Others of you are going to get stuck, and you're going to say, okay, I know that a triangle has 180 degrees in it, so you're going to take 180 minus 53, 53 minus 53, and you're going to get 74. And if you know that this angle is 74, then you're going to take, okay, 180 minus 74, and you get 106. You'll still get the same answer as the person that did it the other way. Okay, example 3 says when a radar tracks an object, the reflection signals off the ground can result in clutter. Clutter causes the receiver to confuse the real object with its reflection, called a ghost. In the diagram, there's a radar receiver at A and a plane at B, and the plane's ghost at D. What is the value of X? Solve 2 different ways. Okay, so they're giving us a triangle. They're telling me that this is 30 degrees, this is 80 because it probably didn't show up on your paper very well, and this is X. Okay, so they want us to find X. One way to do this is to say, okay, I know my remote interior angles, 30 plus X, has to equal my exterior angle. And you're going to say, okay, so I'm going to subtract 30 from both sides, and I get X equals 50. You're done. Someone else might look at it from the standpoint of, I need to find what this angle measure is. And they would take 180 minus 80 and get 100. So that means that that angle BCA is 100, and then they're going to say that 100 plus 30 plus X equals 180. So I have 130 plus X equals 180, and they're going to subtract 130 from each side. And they get X equals 50. Either way you do it, you get the same answer. Okay, lesson check. Make sure that you've tried these 8 problems before you come to class.